Okay. Welcome. First real class today. I don't know, last week felt pretty real. No, it didn't. No, it didn't. All right. A couple of things administration wise that I want to highlight. So I did start on our Moodle page. I picked the test dates. That's pretty good. And then something else came up, so it'll happen. But we have the test dates, and I'm going to, well, if I can, screenshot this here, and I'll bring it into our notes. And how do I do this again? It's been a while. Okay. Crop this up. So first things first, test number 1 is on October 8th. So that's, I'm pretty sure the Wednesday before Thanksgiving. So before a little long weekend, not after. That's nice, right? You're welcome, you're welcome. And then test 2 is on November 19th. So those, you have to come to class, you have to write them here with me. It'll be so much fun. But that feels like a ways off, but good to know, right? Okay. All right. What else did I want to bring up here? Blah, blah, blah. Oh, okay. It was a little too ambitious. So remember last week I said I'm gonna try to sneak in matrices, but then when I mapped it all out, we don't have time. So we're gonna do logic instead because it's shorter. So no matrices, but we will do logic. It's such a short term with all the holidays. Term 1 is so fast. Term 2 is so slow. You know that, maybe. Okay. And our first day of real material, we're gonna do section 1.1 and section 1.2 today. But you already knew that. And then we'll do 1.3, the equation of a line, on Wednesday. Now the notes that I'll be filling in are these ones here. This is for all of chapter 1. Okay, so that's where you'll find them. I do end up moving things around, but I'll post the notes that we write together after class. Okay. Just like I did here on January 9th. That's not for us. That's for me. Right. Actually, I just haven't removed it yet. That's all. But what else did I do? I opened up your first assignments, your first 2 or 3 assignments, I think. And so, like I said, we're going to do section 1.1 and 1.2 today. And so they'll be due next Monday. I always make them due at midnight, but midnight's difficult, so 11:59 p.m. Okay. And so these are the rules for all the assignments. So I want to screenshot that and talk about that. Let's see if I can pull that off. Tick, tick. All right. Well, it used to be there, but now it's here. Hey. You can see why I have them pre-made, the notes, because it takes me a long time to get them sorted. There we go. Screenshots. Okay. So these are the rules rules for all assignments. Wow, I haven't written in a long time. Hey, smiley face. Okay. For most sections, and so there's an assignment for each section. It's not that bad. We're only going to do half the questions, and each section's kind of short. So, right, but we need lots of practice, lots and lots of practice. And so you'll submit for each section the work for the even exercises, right? 2, 4, 6, 8, blah, 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 blah. I have posted the solutions to the odd numbers, right? So that you can have some solutions to work off of and just kind of see what I did and then maybe recreate the magic, right? In the even exercises. Okay? And so in general, the even exercises, there are some where they made them all kind of join. So there will be a note on that assignment, but in general, just the even exercises. Okay. I'm only grading for completion. So is it a complete? You get a 1 out of 1. If it's not complete, you get a 0 out of 1. Okay. And so within reason, you don't have to do, you should do all of them, of course, right? But, you know, if you run out of time or jumping down to, if you're unable to do a question, right? At least tell me, hey, I can't figure out how to do this question. I ran out of time. I'll come see you. Wow, that sounds great, right? And we'll figure it out, okay? And so, but just most of it done, right? That's good. And you have to submit it as a single PDF. Okay? I think if you're working on paper, then a scanning app is going to be the easiest way to do that. I like Genius Scan. Any other good ones out there? Do you guys use Genius Scan? Cam Scanner is a pretty common one. Scannable is so good, but they make you pay for it now. Ew. Anyways, there's lots of free scanning apps. And so if you need help with setting that up, what I did when I was picking a scanning app is I downloaded all the free ones and I tried them all to see which one I liked. I forgot to delete most of them for a long time. But so I like Genius Scan. I'll put that on here. If you can't have scannable for iPhone is really good, but like I said, they make you pay for it now, so don't do that. If you're working on a tablet, that's easy, right? You can move things around and generate one PDF. It's easy. I want you to submit all the questions numbered. That helps me. And in order, right? 2, 4, 6, 8. Right. So if you're skipping a question, maybe it's nice to give yourself a little bit of room on the page, go back to it and fill it in. Okay? Or you can do what I did, old school, do a rough copy and a final copy. That's a lot of work though. You don't have to do that. Okay. And like I said, if you're unable to do a question, right, you've tried it, right, you've talked to your friends and you just can't get there, that's okay, right? Maybe if you have enough time to work through it, that's great. But I know you guys are busy, working at the deadline usually, right? Not in the beginning, but towards the middle of the semester, I know how it is. Okay, so that's okay. You can just say, I don't know. Okay. Any questions about these kind of assignment rules? Nice. All right. Anything else before we begin? Talking about lines. Start way down here or here. Lines. Okay. Let's see here. I'll bump this up here. Okay, come on. Okay, maybe I won't. It won't let me move it. Oh, I should see. Does it show you? Okay, it shows you what I'm trying to do at least. It doesn't want to let me move it. That's okay. All right. So lines, if I say y equals mx plus b, does that kind of rattle something maybe? We'll get there. But we're going to start like down here. So what we need first for linear equations is, well, we need a coordinate system. Now, the coordinate system that we will use, you might recognize like this. So we've got our x-axis and our y-axis. Okay? They have to be in this order, right? So the x-axis is always down here and your y is always up here. And that's important to memorize. And so this isn't something that I had a hard time memorizing, but I know students have a hard time with it. And I had a student one time, a long time ago, tell me the cutest way to memorize it. And she says, oh, I just think of a guy and he's down here and the y-axis is a tree and it's falling on him. And he's like, no. And that's how she remembered it. So however you need to remember it is fine, right? That's pretty elaborate, but it works. I think it's really cute because then, of course, that makes it the x-axis. No, because it's falling onto the x-axis. Anyways. And of course, you may or may not remember, but any point in this grid, right, we denote it by round brackets, right, like this, round brackets, and then we have the x coordinate and the y coordinate, right? And so your x is going to be whatever value is on the x-axis, and of course the y is whatever value is on the y-axis. Okay? And so those, I assume, you know now, right? And now we can talk about linear equations. Linear equations are things that look like this, right? And in general, right, y equals mx plus b. But like I said, we'll talk about that later. We're going to build up to y equals mx plus b, if you can imagine that. I couldn't see you, sorry. Close all the blinds and now I can't see anything. So a linear equation is just a line, right? And so, of course, it's in the word line, right? But we call it a linear equation. Right? And so equations whose graphs are straight lines are called linear equations. Okay? One way that you could think of it is if there are no powers on the x's or the y's, right? So if you have x to the power of 2, it's not linear anymore, right? So straight lines, there are no powers on the x and y. Okay? And so some examples of linear equations. 2x minus 3y equals 6, right? No power on the x, no power on the y, right? Just a straight line. Okay? And you can rearrange these into the form y equals mx plus b if you move things around, but we won't do that quite yet, right? Just an x and a y, just the y and an x, right? Here's just a y. Where did the x go? What the heck? How about this? If we think about 2y plus 0x is equal to 3, that's allowed. Right? So if there's no x, it just means that it's being multiplied by 0. And usually we just don't write that. Right? And same thing here. X minus 2 is equal to 0. What happened to your y? We can kind of put it anywhere, but let's do 0y plus x minus 2 is equal to 0, or something crazy like that. So if it doesn't show up, it's still sort of there, just being multiplied by 0. A lot of what we're going to do involves graphing a line. Okay? And so we need to be able to draw it by hand. I'll be using Desmos quite a bit. Okay? Have you used Desmos? Desmos, it looks like this. This little guy here. It's a free app. So you can have it on your phone, and you will not have it in the tests, obviously, but you will have it for assignments. And it's a really nice way of being able to check your work and make sure that you're actually drawing the right line, things like that. Okay. So for example, let's see here. You plug in your equation that you want it to draw, and then it'll draw it here. And so if we wanted to do something like 2x plus 3y is equal to 6. Kind of jumps around as you add things, right? And then that's what that line looks like. Looks like a line. Phew. All right, because we're talking about lines. So, and you can click on the points and it'll tell you. You can even kind of drag and, I don't know, let's see here. Can I? Yeah. Drag and right. So that's a nice way to be able to check your work as you're going. Yeah.
Would you, the 6 doesn't matter in that equation, right? You just basically plug in the 2 on the x-axis and the 3 on the y-axis. Does the 6 really do anything?
I think because they're the little multiples, it does, but not really. Okay. Yeah, I picked a bad example. How about 67? Well, where'd it go? Well, it had to move up. There. I was just going to change it to 7, but that works too. Right? And so, new phone, who dis? So, you can always check your work in Desmos. Right? And like I said, you will not have it on the tests, but you can imagine having it. No. Wouldn't it be so nice? Okay. So how do we draw lines by hand? Ugh. Well, all you need really are 2 points, right? Because lines just keep going forever and ever and ever and ever and ever and ever, right? And so as long as you have 2 points, let's say these 2 points, right? And something straight to connect them, that's all you need. And then the lines just keep going and going and going, right? So you could zoom out, zoom out, zoom out, zoom out, zoom out, and it'll never stop, right? And so, but you really only need 2 points on the line to be able to draw it. So we use that a lot. So a line is completely determined by 2 points, right? Which means that we only need to draw 2 points and then connect them. So to graph a linear equation, we need to find the coordinates of 2 points. And so usually what I do is I just pick convenient values of x and y, right? And then I plug them in, and you can solve for the other variable. Okay? When I say variable, I mean x or y or something similar, right? Or t is pretty common, right, for time usually, things like that. Okay? So just a placeholder for a number. Okay? So what if we have to sketch something like sketch 2x minus 3y is equal to 6? think I did. What did I just sketch? Did I do that one? 2x? I imagined it. No, I did plus 3y. Well, in this case, 67. It's so different. So we need 2 points. Okay. And usually what I do is I set up a table. So step 1, set up a table. I like to do it as x. So I pick values of x, right? And then I solve for the value of y. Right? And so here I have x, and then I have 2x minus 3y is equal to 6. What's my favorite value of x? 0, because the math is so nice, right? And so here you can pick any value, right? Any value you want, but like I said, I like to pick convenient values, right? Values I want to do math with. Okay? So let's see if I can be consistent here. 2 times 0 minus 3y is equal to 6. Well, the 2 times 0 is going to go to 0, right? That's 0. So then I just have negative 3y. You don't want to lose that negative, right? But then I have negative 3y is equal to 6. Now, well, first, I'm going to bump this down because I can. But I want you to always try to stack your equal signs. Okay? It's just proper math. Okay? So when you're working, it's tempting to go across this way, but it gets really hard to read if you're trying to read it back. Okay? And so here I have negative 3y is equal to 6. How am I going to solve for this y? I have to divide both sides by negative 3. So I get y is equal to 6 divided by negative 3. Continue that highlight. What's 6 divided by negative 3? I'm going to go for negative 2. Oops. And I'll keep that highlight going. Which means what? Which means that when x is 0, on this line, y is negative 2. Okay? And so then we can add another x, y column here. When x is 0, which we picked. Right? Nice, easy math. I think you'll be able to do this a lot quicker, right? Just in your head. You can use a calculator, encourage it, right? And so I always use a calculator. I never do math in my head. So then the point that my first point that I would draw is at 0, negative 2. Let's get a second point so that I have a good idea of what grid to draw. Since I'm sketching it, I want to make sure that I have enough room for both my points. Okay. What's another value of x that we could, what's a nice convenient value of x? Maybe 1? No. Yeah. Let's do it. What if x is 1? Then I have 2 times 1 minus 3y is equal to 6. You could have put in values for y as well, right? Or instead, it doesn't matter. You would just find different points on the line. Oops. Okay. This becomes 2 times 1 is 2, minus 3y is equal to 6. What sort of math do I have to do first here? Well, I need to subtract 2 before I can get at the negative 3y, right? So I need to subtract 2 from both sides, and it makes a little bit of a mess, which is why I hesitated, but we can handle it, I think. Can't come up with a better value. Let's see here. I'm going to add a page. Move this down. Okay. So now I have negative 3y is 6 minus 2. Moving that 2 over to the other side. So then I have negative 3y is equal to 4. Solving for the y, dividing by negative 3 on both sides, I get y is 4 over negative 3, or negative 4 over 3 if you prefer. Like I said, I don't do math in my head. And is this a nice, it's a bad decimal, isn't it? 4 over negative 3. It's bad. So bad. It's called what? An irrational number, right? Because it just keeps going. So you have y. This line on top means it just continues forever and ever. Okay? This is when it continues forever and ever, it's called an irrational number. I don't test you on that, but it might be nice to know. If you did, let's see here, I'll do an equal sign and then an approximately equal sign, right? A squiggly equal sign. I should make it more obvious. There. What's the difference between an equal sign and approximately equal? I would say it's approximately equal if we just round it, right? And so this is what we call an exact answer. And so that's why it gets the equal sign. And technically, because I put the bar over top, it's still an exact answer, although I would prefer to see this, right, as your exact answer. And this, because I've rounded, right, then I use the squiggly equal sign, and it's approximately equal to. So this is approximate answer. So that's the difference. Yeah. Yes. How's there? Nice. It's not a nice point, but I have a really hard time thinking of where 4 over negative 3 or negative 4 over 3, because they're the same, right, would fall on a number line, right? Whereas if you look at negative 1.33, it's a lot easier, right? And so usually for points like this, we would use the approximate answer, right? But I'm happy with either or. Okay. And so what's my coordinate here? Uh-oh. Nope. At the very end, I get when x is 1, y was negative 1.33. like I said, it's easier to draw the approximate answer. Okay. Finally, I just have the 2 points. Right? I feel like you'd have been done a long time ago. I wasn't blabbing about it. Oh, and I should make this green to match. Green, because we just picked it. Right? So if I have to sketch this line, right, I need to have room for x equals 0 and x equals 1, but I also need to have room for y equals -2 and y equals -1.33. Right? And so my graph, I'll try to keep it on the same page here. I need more room down this way. We can put x equals 0, oops, and x equals 1, x equals 2, and we can have your y -1, -2, -3. Of course, it goes up too, but we want to draw lines down here. So when x is 0, y is -2. Right? This is at 0, -2. When x is 1, then y is -1.33. Let's see if I can do, we're just sketching it. So let's do something like this. So when x is 1, y is -1.33. Now I have these 2 lines, right? And you can take any straight edge. Well, this one might be too short, but you can connect them, send the line. And usually what I do is I just, in a test, well, this, I don't know what this is. This is a straight edge. I'm just gonna take the page and I bend it over gently and I use it as my straight edge. You don't have to have a ruler or anything. It's not that picky. But now let's see here. I'm just gonna go for it, I think, or try. Well, luckily my iPad corrects me. There. This is the line. 2x minus 3y is equal to 6. How do we check our work? You go to Desmos and change this to 2x minus 3y is equal to 6. Well, I'm way zoomed out. Once I'm here, we got that one right. How about if I trace it to when x is 1? Come on. Here, hey, looks pretty good. 1, well, it's hard to get there, but you get the idea. -1.33, we know what it is, right? But that looks like what we did, so that's good. Phew. Right. Well, we can move on. Okay. We'll see something like 2y is equal to 3 and x minus 2 equals 0 on the next page. So I'll hold off on those. But notice that there's only a y or only an x, right? And so those are special cases. But if we think, okay, fine. Get carried away. What if 2y is equal to 3? That's okay. Consider 2y is equal to 3. right? Or what we said was you could rewrite this as 2y plus 0 times x is equal to 3. Doesn't matter what value of x you put in there. You can put in any value of x, right? And it will not make a difference, right? In fact, 2y is equal to 3 simplifies to y equals 3 over 2, or 1/2. And so for any value of x, right, it doesn't matter what value of x you put in there, you're always going to be at y equals 3 over 2, right? Or y equals 1/2. What does that look like as a graph, right? If y is always 3 over 2 for all the values of x, that's a horizontal line, right? And so it'll look something like this, right? Y is 1/2, because it doesn't matter what value of x you put in here, it's just always going to return y equals 1/2. This is a horizontal line. So this is a horizontal line. And spoiler alert, the other one where we only have an x is going to be a vertical line. Okay? And how I remember the difference between a horizontal line and a vertical line is because the horizon, like this, right, where the sun sets and rises, that's the horizon. It's like this. Right? So here you have a sunshine. Whee! Sun. So it's a horizontal line. Okay? What if we consider the other one? I already told you what to expect, but it's nice to see. X minus 2 is equal to 0. Let's or we could say something like 0y plus x minus 2 is equal to 0. Didn't change anything in the equation. I'm just multiplying something by 0. But again, it doesn't matter what y I put in here. I'm going to get the same thing. So if x minus 2 is equal to 0, then x must be equal to 2 always. Right? So that looks like this. So I've got my x coordinate. I should have labeled these x and y. Oh, that was sloppy. It's even sloppier than usual. There. So if x is always equal to 2, then somewhere here at 2, I'm going to have a line like this. Oops. Pretend that goes straight up and down. So this is called a vertical line. And this is at x equals 2. Okay. And again, it doesn't matter what value of y I put in here. I always get the same value of x. Any questions so far? I hope you'll just jump in. Similar to that are intercepts. Intercepts are special cases. Okay? The points where a line crosses the axes is called the intercept. Okay? And of course, if we have an x-axis and an x-axis and a y-axis, like this, and we just draw a line. Let's say we draw a line like this. for fun. Then this is called the y-intercept, right? Because it's where it intercepts the y-axis, right? And so this is called the y-intercept. And that is where x is equal to 0. It's a special case, which we already used, right? I used x equals 0 as an easy value of x. Right? And see if I can branch out with some different colors. Not really, but how about light green? There. Where it crosses the x-axis is the x-intercept. And similarly, that's where y is equal to 0, right? This is where y is equal to 0. So if you force y to be 0 and solve for that value of x, that's the x-intercept. And if you force x to be 0, right, then you've solved for the y-intercept. Right? Nice. Anything else I wanted to say here? I don't think so. Move this up. This is, so parametric form, it's not going to come up ever again. It's just a fun thing, I guess, that they like to introduce. And so just so that we've seen it, so that we're prepared, we can also have, so in some higher level math, you might see lines in parametric form like this. Okay? And so what's new here? X equals 3 plus 2t, right? And then y is 1 plus t. So they've got this kind of linking variable of t. Okay? And so just for practice, and like I said, if you don't like this, it's okay. These t's, we're not going to work with them, right? You'll have some practice problems, but nothing crazy. Okay? The t itself is called the parameter or a dummy variable. But if you've done stats, then a dummy variable is something else. So kind of confusing. Okay? Or if you've some stats courses. How can we find these lines? Well, it's just an extra step. Okay? So parametric lines can be graphed by finding values for x and y by substituting values for t. Okay? So you can plug in a value for t, you pick values for t, and then you can solve for what x is, and at the same time what the y is. Right? What does that look like? If we use these equations here, these parametric equations, can I squeeze it onto one page? Okay. Let's see if I can bump this up just a smidge. Need more space. But it's not worth a ton of space. Okay. So same idea as before. I'm going to have a column for the t's that I pick, right? I still need 2 points. Okay? And so I'm also given that x is 3 plus 2 times t. So that's going to be how I solve for my x. And to keep it nice and tight here, y is 1 plus t. And eventually, I'll have a coordinate xy. Hopefully, I can pick values of t that give me really easy math. Right? How about t equals 0? My go-to. But I'll use a different color just to indicate that I just picked this number, right? You could use 1.5 if you wanted to, but that's harder, right? It's okay. You'd still get the same line, right? So if t is 0, then x must be 3 plus 2 times 0. So then x must be 3. If t is 0, then y must be 1 plus 0. So y must be 1. Making my first coordinate xy. 3, 1. Should we go crazy and use t equals 2? Wow. Oops, I wrote 0. 2. I think we can still handle it though, right? As long as you remember to do 2 times 2 first and then add it to the 3, right? Multiplication before addition. All right, so then x is 3 plus 2 times 2. Oh, and I should use the same color. All right. As long as you remember to do that 2 times 2 first, all right, so 4, then you get 3 plus 4. If t is 2 and y is 1 plus t, then I'm going to go y equals, I'm just going to go for it. I think we can do it. 1 plus 2. Did you think that was going to happen today? 1 plus 2 is 3. Well, it happened, but in a weird way, right? Not in a fun way, maybe. But we have a coordinate, 7, 3. So now I can sketch these, but I didn't give myself any room, did I? Fine, I'll do it here. On my x-axis, to sketch my graph, right, I need to make sure that I have enough room. My x's are going between 3 and 7, so I definitely want to have quite a bit of room out, right, on my x-axis. My y's are between 1 and 3, so I don't need a ton of room. They're all positive. So I've got a pretty good idea of what this graph might look like. Let's say 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7. Oh well, that's all I needed. 2, 3, 4, 5, 6, 7. My first point is when x equals 3, y is equal to 1. And when x is equal to 7, y is equal to 3. 7, 3, and 3, 1. Now I've got 2 points. Can grab my edge of paper, connect them. Actually, will use the paper. Or maybe not, because it keeps moving. Good. That's how you draw the line with a parametric equation, or in parametric form. I think it's kind of fun. So play around around with it. See how you like it. Any questions about that though? We've already talked about horizontal and vertical lines, right? But here are the facts about horizontal and vertical lines. Okay. So when an equation of a line only has one variable, right, either an x or a y, I'll clarify that here, x or y, you get either a horizontal or a vertical line. Right? I always just recommend that you draw it out. You don't have to memorize these points, right? Because they're kind of confusing, right? But if you start to draw it out, just like we did earlier, right? With these two, right? Then you can see it right away, right? So if you have y equal to some number, then it becomes a horizontal line because it doesn't matter what x is, right? And so the technical way of saying that is the graph of the line, or I guess I was talking about this one, but let's talk about this one. X equals a, where a is some constant, is a vertical line, right? So up and down like this, that passes through the point a0. And so when y is 0, it's at a, okay? And every point on this line has an x coordinate equal to a, regardless of the y coordinate, right? Whatever y you feed it, it's just at a. Okay? And so what does that look like? Because like I said, this is kind of a gross way of just saying this. X equals a, oops, better make sure it's actually straight, is a vertical line. And same idea, the graph of the line y equals b, where b is a constant, is a horizontal line, right? It doesn't care what x is, it'll just always be at y equals b. Right? And so that is going to be on this side. Y equals b is a horizontal line. And we already saw examples earlier. I guess I skipped ahead in my mind. But see examples from earlier. Nice. Any questions? No. Warmed up with lines. How about the slope? Wow. Crazy. Crazy, crazy, crazy. Now, you will have a formula sheet, and I just didn't print them off for you now. And so far, we haven't really seen much worthy of a formula sheet, but this will be on your formula sheet. This is on the formula sheet. So we've drawn some lines. Some of them went like this, and some of them went like this. And first things, I guess I could use some of this space here. Right. No. Stay here, Emily. Okay. Right. So the slope of the line can be really, really steep, or it can be just kind of flat, or something in between. Okay? And so we'll be able to calculate the slope of a line right? Given 2 points. Just like how we drew a line with 2 points, right? And so generically, if we have x1, y1 as our point number 1, so notice how I'm just using subscripts, right? This is point number 1. And this is point 2, generic points. Okay? x1, y1, x2, y2. So if we have these 2 points that are on a line, then the slope of this line, bless you, is, you might remember, rise over run, right? That's the slope, okay? But if you want just the math, you would do y2 minus y1 over x2 minus x1. In fact, let me move this up here because I thought of some things worth writing here. Generic grid. I've got point number 1, let's say x1, y1, and let's do a downward slope to point number 2, x2, y2. Now it doesn't matter which point you make point number 1 and which point you'll make point number 2, okay? As long as you keep track of which one you're using as which. Okay? So then, okay, if we trace this down, this is at x1, that first point, and on the x-axis here, you're at x2. Same thing with the y-axis, you're at y1, and you're at y2. How do you find the rise over run, which we're probably more familiar with, right? So, or m, lowercase m is what we use for the slope. I'm not entirely sure why, but it just is, okay? And so I should look into that. I should figure out why we use m. It's weird, right? But we do. And so m is rise over run. So if you have these generic coordinates, right, x1, y1, x2, y2, how would you find the rise here? This would be the rise. You want to find the distance between y1 and y2. You could do y2 minus y1. You could also do y1 minus y2, but we have to be consistent. And so the rise is going to be y2 minus y1. I'm noticing I should have done a positive slope. Should I change it or keep it the same? It's a little confusing if I don't change it. No, we can do it. The rise, you can do y2 minus y1. That's that distance. Just imagine different numbers. 1 minus 3 would be your rise. Does it make sense that it's negative? Yes, because the rise is down, right? And so we get a negative rise if you're going down, and you get a positive rise if you're going up. And so here, a negative rise, can I just call it rise in air quotes? A negative rise means we are going down. about the run? I'll use a different color here. The run is positive, right? And so here, how would I calculate the run? I'm going to do x2 minus x1. That tells me, and just to match here, right, x2 minus x1, that gives me that run. And so that's where this equation comes from. It is rise over run, and so if you prefer that, that's great, right? But there will be lots of examples where you'll be given 2 points and you have to find the slope and then find the equation of the line, maybe find an equation of a line that's perpendicular to it, right? That kind of thing. And so we're just building up slowly. But like I said, this formula will be on your formula sheet. But you'll have it memorized anyways, I think. Okay. And I guess I should draw a line here. Hey, that's pretty good. Oh, wouldn't you know it? An example. What if you have to find the slope of a line that passes through these 2 points, -2, 3, and 4, -1. And we'll graph the line as well, right, just so we can see what's going on. All right. As an exercise, we're going to first make this point number 1 and make this point number 2. And then we'll do it again where we treat this little guy as point number, wait, hey, it didn't write down. Point number 2, and this one is point number 1. And you'll see that they're the same. Right, so it doesn't matter as long as you are consistent. Here we go. We want the slope. And just for general math rules, I always want to see the empty formula that you're about to use, right? And then fill it in. Right? It's kind of proper math that we're working with here. Right, so the formula that I'm about to use is y2 minus y1 over x2 minus x1. M equals y2 minus y1 over x2 minus x1. Notice that these are just subscripts. Right? Just which point did they come from? Okay. Which means if this is point 1, x1 is -2 and y1 is 3. If this is point number 2, then x2 is 4 and y2 is -1. So let's plug that in. Here I need y2. y2 is point number 2, the y coordinate, -1, minus y1, which is from point number 1, the y coordinate, which is 3. You don't want to lose any negatives or anything like that, right? You want to be really careful, right? But once you've got them kind of mapped out, you'll be all right. Over x2 minus x1, x2 is 4 and x1 is -2, right? I just throw brackets around there because if I subtract a negative, right, that's really adding, right? You can use your calculator, it's all right. Okay. And so now I get a slope of -1 minus 3, which puts me at -4 over 4 plus 2, which is 6. Okay. I'll say now let -2, 3 be 0.2. And this is just for practice, be 0.1. So swap them. Again, you're gonna write your, I know it's gonna be nighttime out there. You're gonna write your empty formula, right? And then fill it in. Y2, now my first, usually I just let my first point be 0.1 and my second point be 0.2, because this is confusing, right? But we're practicing, we can do it, right? So my Y2 from point number 2 is going to be 3. And I usually have to use my hand and map it out. Y1 is the Y from point number 1, which is -1. So minus -1. Divided by, we're doing good, -2 minus 4. I get 3 plus 1 is 4 over -6. I'll bump this down here. Note, -4 over 6 is the same as -6 over 4, which is the same as if the negative is just out front. Nope. Hey, no one stopped me. Somebody stop me. Is the same as, hey. Wow, I was really sloppy here. -4 over 6 is the same as 4 over -6. There we go. Which is the same as if the negative is just floating out front. Wow. -4 over 6. So they're the same. Right? Which makes sense because there are 2 points that are supposed to be on the same line, so it has to have the same slope. Okay. And I guess we should graph this. Man, I really don't like graphing by hand. Can you tell? So boring. I'll move this down here. Okay. How are we going to graph this thing? You've got a couple of options for drawing this graph, right? I would say the easiest thing to do is you have 2 points, just use those. You don't have to do anything crazy. You already have 2 points, and that's all you need to draw a line. So let's do that. So -2, 3. Well, I need to make room out this way then. Oops, -1, -2, let's say. Let's see, what's the other one? I didn't give myself enough room. 1, 2, 3, 4. It's not going to be a very beautiful graph, is it? That's okay. -2, 3 is somewhere here. And 4, -1 would be somewhere here. And if I connect these, just gonna go for it. Not bad. Then I get this line. And it has a slope of -4/6. I just want to make sure. Okay, now is a good time to talk about it. Here, we had a negative slope, right? And all negative slopes will have this kind of downward trend. And so here, all negative slopes, oops, will look like this. Oops. Heading down. I did not leave myself enough room. Oh no. Come on. Move these back up. I made a mess. Nope. Yeah. Versus a positive slope. A positive slope is going to be going up, 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 up. Right? So if there's no negative on your slope, then it's going to be increasing, right? As your x is increasing, your y is also increasing. Right? That's a positive slope. We will see that again, but I wanted to introduce it here first time, and we'll see it over and over again. So, are you convinced that it doesn't matter which one you use as 0.1 and 0.2? You can just use, as long as you pick a setup that works for you, right? In fact, maybe plugging in values was a little bit easier, not just because it was our second time doing it, but a little bit easier if you let the first one be 0.2 and the second one be 0.1. I find that too confusing, but if you can handle it, might be easier. Play around with it. Find the slope of a line that passes through the points 2, 3, and 2, -1. So now I'm going to let this be 0.1, but you're welcome to try it and make sure you get the same answer as me, right? Reversing them, 0.2, 0.1, crazy. 1.2, and we have to find the slope, and we have to graph it. The slope is y2 minus y1 over x2 minus x1. -1 minus 3 over 2 minus 2. Bless you. I'm gonna need another page here. These guys. Uh-oh. What happened? you think about, okay, if x is 2, it gives me a y equals 3, and if x is 2 again, it gives me a negative 1. You have to visualize that. What does that, that feels like this, right? Feels like a vertical line. Okay? And so what happens is the slope is negative 1 minus 3, which is negative 4. 2 over 2, 0. Oh, where are my stickers? Uh-oh. There's a double exclamation mark one that I use all the time. Where is it? This is important. No, not that one. Aha. Can't divide by 0. That's illegal math. Right? And so we can't divide by 0. It's illegal math. Which means that this slope is undefined. If I do 3 dots like that, do you know that that's therefore? Shorthand for therefore? Because I do use that quite a bit. Therefore, the slope is undefined. Okay. And this is the troublemaker there, dividing by 0. It means that there is a vertical line, right? If we think about 2, 3, it might be somewhere, I don't know, here. 1, 2, 1, 2, 3, negative 1. 2, 3, let's put her there. This is just to sketch it out. Right, 2, negative 1. So this is a vertical line. At x equals 2. So when it's a line like this, there's no slope. Right? It's undefined. It's still a line. It's a vertical line with no slope. It's weird. But if you think about it, there's no run. Right? So it can't have a slope. So that's a special case to keep an eye out for if you ever end up dividing by 0. It's undefined. Any questions about that one? Because it's different. What if we have to find the slope of the line that passes through the points -1, -4, and 3, and -4, and we have to graph it? Wow, we're doing a lot of the same stuff, huh? I know. Can you believe it if I say I'm going to make you do it on the test as well? Good. Because I can't seem to do it the clever way. I'm going to let this first point be point number 1 and this be point number 2, even though it's kind of more confusing. But you should find the same answer, right? And so let's see here. M is y2 minus y1 over x2 minus x1. Y2 is -4 in that case. and y1 is -4. Uh-oh. That doesn't look good for us, does it? It's okay. It's okay. X2 in our case is 3 and x1 is -1. So once I do this, oops, -4 plus 4, I should throw some brackets around there. I don't have to, but it makes it cleaner looking. Yeah. Question. Yeah, nice. Felt like a question, but it's actually an answer. -4 plus 4 puts us at 0. 0 divided by anything is just 0, right? And so, but we'll do it 3 plus 1, 0 divided by 4. So here, 0 divided by anything is 0. So it is defined, right? Unlike the other one, the vertical line. What do you think this one is? It's another special case of a horizontal line, right? Because what's the rise of a horizontal line if you imagine it? Right? There's no rise, right? But tons of run, infinite run if you want, right? And so here, if we take these points and sketch a graph, oh, -1. All right, -1, 1, 2, 3. Oh, it's going down. Of course it is. Hey. How about I cheat and do that? -1, -2, oops, -3, -4, blah, blah, blah. Then I have a point at -1, -4. Maybe here. And at 3, -4. Maybe here. So the slope, I want to kind of match, I'll use orange. Right here we have a horizontal line at y equals -4. So if the slope is 0, then you know you have a horizontal line. Let's see what time it is. Let's see here. Wow, time flies when you're having fun. Don't worry, well, okay, so we do have a few more examples, but I think we're getting the hang of it. Right. What if you have to graph a line? Oh, this one's different. It's kind of fun. Graph a line that passes through the point 1, 2 and has a slope of -3/4. How are you gonna approach this? Well, you got a couple of options, right? You could, I think the easiest way to do it is to draw the point 1, 2 and do a rise of -3 and a run of 4. Oh, how about that? So what are we gonna do here? If this is 1, let's say 2. 1, 2, -1, -2, -3. Let's do 3 on here for kicks. So what I'm going to do, and what I would suggest you do, is start at this point. 1, 2. I didn't give myself enough room. Still. For what I wanted to do. Let me just give myself a couple more notches here. Whoops. 3, 4. We'll go 1, 2. So the first option is a rise of -3 and a run of +4. Right? Or what's the other option? A rise of +3, but a run of -4. Okay? Either way, the slope is going to be -3/4. Okay? And so here we can have option 1. Let the rise be -3 and the run be 4. A negative rise, we said, is actually going down 3. Right? And so then from here, from 1, I'm going to go 1, 2, 3. That's a rise of -3. And how about a run of 4? Well, I'm going to keep going here. I probably should have mapped this out in advance because I'm not very good at winging it. There. And then I'm going to have a run of 4. So from 1, I move out 4. 1, 2, 3, 4. So like that. What about option 2? You can let the rise be 3 and the run be -4. Right? A negative run would be to the left. And so then the run would be -4. What would that look like? So now I'm going up 3. 1, 2, 3. I'll give myself another one here. 5. 1, 2, 3. And then a run of -4. Well, I can get to the y-axis by moving 1, but I still need to move to the left 3 more points, putting me at, let's say, -3 here. So first I went up, and then I went over. First I went down, and then I went over. Now, if my scale had been better, these would all be on the same line, right? Doesn't matter which way you went, right? These are all on the same line with a little bit of luck. Okay, well, I missed the pretend. I shouldn't let it adjust my, there. Hey, I didn't draw it through. Anyways, you get the idea. So, same line. So it doesn't matter which way you go, right? One of them has to be negative, right? But it doesn't matter which one. What if you have to find the slope of this equation of a line? we already did some of this work, right? What would you need to do? I think the easiest way to find the slope in any scenario is to have 2 points, right? And so you need to find 2 points on the line, right? An extra step, but we already did it, right? And so let's see here. Or I think we did a different one that was very similar. Let's just do it over again. We'll be so fast today now that we've seen it. So here, find the slope. First, find 2 points on the line. So we can plug in convenient values of X or Y. Hey, how about that? How about we let X be 0, and then we can let Y be 0. Solve for X and Y, or Y and X. Let's try that. Crazy. What if X is 0? Then I can say that 2x plus 3y is equal to 6. Then y must be 2 times 0 is 0. That's why I picked it, so I don't need to write it down, right? But 3y is equal to 6 means that y is equal to 2. And what if I force y to be 0? You could set up a nicer table, but I'll just do them side by side like this. Then I can have 2x plus 3y is equal to 6, and I want to solve for x, right? Forcing y to be 0, I get 2x plus 0 is 6, and so I get x must be 3. Which means that my point number 1 can be 0, 2, and my point number 2, just be careful because the x goes first, right? 3, 0. Now I have 2 points, and I can solve for the slope. M is y2 minus y1 over x2 minus x1. Okay. Keep needing more room. I always do, though. It's nothing new. I'll let my first point 0, 2 be point number 1, and 3, 0 be my point number 2. And here we go. 0 minus 2 over, let's see if I can handle this, 3 minus 0. I get a slope of negative 2 divided by 3. Or you can rearrange this into the form y equals mx plus b, which means you have to solve for y. So alternatively, and we were supposed to do a lot more work, but this is what we're getting to. Alternatively, rearrange the equation solving for y to get the form y equals mx plus b. That's a b. a lowercase b, where this is the same slope that we've been working with. All right, it's the same m. Okay. So here, the value attached to x is the slope. So let's try it. We had 2x plus 3y is equal to 6. 2x plus 3y is equal to 6. So we're going to solve for y by first subtracting 2x over to the right-hand side. So I get 3y is 6 minus 2x. And then I have to divide both sides by 3. Now we're only interested in the slope, right? So we can kind of ignore the rest, but we have to do it properly still. Worse, but we're getting pretty close. So y is 6 minus 2x all divided by 3. That's important. It's all divided by 3. Because then if I split this up, right, 6 has to be divided by 3, but negative 2 also has to be divided by 3. Right? And so what does that look like? I'll bump this down one last time, hopefully. Y equals 6 over 3 minus 2x divided by 3. Or 2 over 3 if you want, times x. Hey! We found a slope of negative 2 over 3. And we found the same slope attached to the x. M is the same. Whee! Right? But with practice, I think solving for y and rearranging into y equals mx plus b is going to be a lot quicker, right? You still have the tools if you want to solve for 2 points. Use those points to find the slope. Totally fine, right? However you want to do it works for me. In y equals mx plus b, you might remember, so just like before, the x's and the y's, they're just placeholders, right? They're just variables. The m is the slope and the b is the intercept, the y-intercept. Okay. And so here, b is the y-intercept. And I only bring that up because it's going to make the next question a lot quicker. I'll even bump this up because we already talked about y equals mx plus b, right? M is the slope and b is the y-intercept if you've managed to rearrange it into this format, right? If you've solved for y, moved everything over, simplified all your x's, right? So now if you have a line, we can find the slope and we can find the y-intercept. Is this in the form y equals mx plus b? Yeah, it is. Y is 3x plus 2. So I have a slope. I have a slope of 3 and a y-intercept of 2. Making sure everything is simplified and solved for y. I get y equals mx plus b again. Phew. Good thing we know about y equals mx plus b. Otherwise, we'd have to do a ton of work. So I get a slope of negative 2 and a y-intercept of 5. Notice that whatever is attached to the x, right, including that negative, is the slope. And same thing here. Y equals 3 over 2x minus 4. I have a slope of 3 over 2 and a y-intercept of negative 4. Nice. And then for Wednesday, we'll find the equation of a line, right? But of course, we'll build on all these slopes and things. Any questions? All right. Good night. See you Wednesday. And you've got those two assignments, 1.1 and 1.2. Wow.